Hi, this is Dave Littman with Truth in IT, and today I am speaking with Phil Miller. Phil is with Charmworks. Phil, welcome.
Hi, Dave. Thank you.
All right. So, hey, we're talking about Supercomputing 16, and we're talking about you guys exhibiting there. And what we want to talk about is your new solution, Charm++. So, tell us a little bit about that, and why that matters to the supercomputing world.
So Charm++ is a set of software programming tools and a parallel runtime system for writing distributed and shared memory parallel applications.
Okay.
It runs on everything from the smallest multi-cores in phones and laptops up to clusters and then the largest supercomputers in the world. And it includes integrated support for accelerators like GPUs and Xeon Phi as well. So our software is based on 20 years of research heritage from the University of Illinois Parallel Programming Laboratory, and it embodies and automates a lot of that knowledge from those decades of research.
Okay, cool. And when we were talking a little bit before we started recording, you'd mentioned that it's different from another type of technology called MPI. Can you talk about sort of the differences between Charm++ and MPI, maybe?
Sure. So MPI is, of course, the most ubiquitous method for programming these large parallel machines. And Charm++ is actually second in usage by number of applications and cycles used to MPI on every system we've surveyed. So Charm is seeing growing use among academics, government labs, and industry. And the difference between Charm++ and MPI that we like to emphasize is that in MPI, the programmer writing whatever application, who's usually a domain expert in whatever field of science or engineering they focus on, is responsible for everything. Mm-hmm. They control every processor, and they have to solve all of the problems. Mm-hmm. Which pushes them to not only have to be an expert in their own domain, but also to have almost a graduate level education in computer science to get the kind of performance that they want. So we aim at giving these sorts of developers much higher productivity through what we call separation of concerns, where we let them focus on their problem domain and we automate all of the other responsibilities of the computer scientist, and where they can't be automated, we make it easy to collaborate between the domain experts and the computational experts to improve the productivity in getting the highest performance and the fastest results.
So, Phil, besides making it easier for scientists so that they don't have to be computer scientists as well, what else in the market is changing that sort of has made it fertile ground for Charm++?
So there are changes coming from two very different directions. One of those is that the applications themselves are becoming more sophisticated to meet growing demands for the accuracy and the fidelity of simulations. And so they're using more kinds of physics, more advanced numerical methods, and so forth that put a lot more pressure on how these applications get written. And in the other direction, hardware is becoming more variable and more complicated. So you'll see mixed hardware even in a given system. You'll see hardware performance that changes, that's variable within a system, and then that might change dynamically during the course of execution. And our software can account for that much more automatically than MPI applications written manually can.
Okay, cool. And you guys are involved in a variety of things at supercomputing. Talk to us a little bit about that.
So we'll be exhibiting at a booth. That's, I believe, well, I'll get you the number later. Sorry.
Okay.
Have a BOF session. That's a birds of a feather session on Wednesday during the lunchtime slot.
Yeah.
That we'd like to see a big crowd at. We'll be talking about several recent application developments, new features and functionality that's being added.
Yeah.
And we'll also be doing live demonstrations of our fault tolerance functionality using a small cluster that we'll actually bring right out on the exhibit floor. And attendees are welcome to walk up and unplug a node and see an application keep on running with a live interactive visualization connected to the running code.
Oh, fun, fun. Well, you know, as I said before, I wanted to just hop through the screen and come over to your lab and see all the cool stuff that you guys are working on. And I know that at supercomputing, you know, you guys will have a crowd that's energized to see what you guys are up to. But I do have one question, and it's sort of
Yeah.
aside from the computing, it's aside from supercomputing, just for the geek in me, what is the coolest thing that you think that you guys have worked on so far?
So the thing that I like to show people is a cover article that appeared in Nature a couple years ago, illustrating a combination of computational work and experimental lab work by a group of our collaborators that ultimately illustrated part of the structure of the HIV virus and produced some very striking artistic visualizations, as well as deep insights that will hopefully help improve health.
Fabulous, fabulous. All right, Phil, that's a great story. Thanks very much for taking the time to speak with us today.
Thank you.
All right, so hey, we've been speaking with Phil Miller. Phil is CTO with Charmworks. Check him out at SC16. We'll be posting the booth number here in the video. Thanks for watching, and make it a great day.
Thanks.